Okay, good afternoon. Let's start. Okay, paki-on sa lights sa back so that I can okay, so last meeting we talked about this algorithm. Okay, this one. Okay, and then we're going to improve this algorithm by adding a pivot. So the goal of improving this algorithm is to reduce the time and space, of course, or in this case, the number of iterations. Okay, as you can see, we have all of these iterations only to determine the maximal. So the maximal is 1, 2, 3, 3, 4, and 5. Okay, so in this case, we have this algorithm. Yan. Okay, so to improve this is to add a pivot. Okay, pivot. So you added these two statements. So I have here this statement and this one. So save everything except for these two. Okay, so as you can see, you need to choose a pivot and get a value u from the union of p and x. Okay, so let's start first with our initial input. Okay, which is null, all vertices, and null. Okay, which will result to the following: Rp and x as our first instance, okay, of our recursion. So next is this statement. You're going to choose a pivot. So you're going to union p and x. Okay? Since p is 1, 2, 3, 4, 5, union this with x will result to the same thing. 1, 2, 3, 4, and 5. Okay, diba? Next statement, you now have a value of u. Okay? And then you're going to substitute that and get p intersection of neighbors of u. So for u equals to 1, 2, 3, 4, and 5, okay, you're going to intersect the value of p, which is 1, 2, 3, 4, 5, with the neighbor of each u. Okay, ito. Yan. So this is our graph. This is our graph. Okay. First is p intersect, okay, with the neighbor of u. So u, neighbor of 1. Okay, what are the neighbors of 1? 2 and 3. Okay, that's the neighbor of 1. Tama? Okay, neighbors of 2, 1 and 3. Listening. U, next is, if u is 3, okay, u is 3 is 1, 2, and 4. Yan. So, neighbors of 3, 1, 2, 4. Okay, check. Neighbors of 4, it's just 3. Neighbors of 5 is null. Yan. Okay. Next is intersection. Since this is the entire p, intersecting 2 and 3 with this p will result to the same thing. So this will result to 2, 3, 1, 3, 1, 2, 4, 3, and then null. Okay. Next is you're going to get the largest number of vertices. In this case, we have this one. Okay, this is 3, this is 2, this is 2, this is just 1, and this is null. So we have this, u3. Okay, so we're now going to assign the value of u to this. Okay, ganyan. So we now have p neighbors of 3. Okay, ganyan. So, what are the neighbors of 3? The neighbors of 3 we have, okay, 1, 2, and 4. 4. Okay, this is P 1, 2, and 4. Okay. Yan. So, P is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 5. Yan. So, we have 1, we have 2, we have 4. Okay? The only thing remaining now is 3 and 5. Yan. So, that's the answer. So, meaning we have two values of B. So, B can either be 3, okay, or 5. So, in this case, as you can see here in our recursion tree, this is for B is 3, and this one is for B is equals to 5. Okay? Yan. So, for your exam, you will be given a graph like this one, or maybe a different graph, because I already shown you the answer. And then, you're going to solve for the recursion tree. Okay? So, recursion tree for pivot. Yan. Because the without pivot version contains a lot of recursions. Okay? So, let's proceed. So, since B is 3, we're going to solve for this section of the left node of the tree. So, in this case, what's the value of R, P, and X? Okay, so the value of R is the value of B, which is 3. Combine it with R. Since the value of R is null, and the value of B is 3, so this is 3. Okay, so let me just correct the slide. So that is 3. Yan. Okay, the value of B. Okay, because we have 3 and 5, di ba? Okay, tama? 3 and 5. So, the value of B and combine it with R. Okay, so that's 3. Yan, correction lang. Okay, next, what's the value of P? What are the neighbors of 3? The neighbors of 3 is 1, 2, 4. So, this is 1, 2, and 4. Intersect with the value of P, which is 1, 2, 3, 4, 5. Okay, so we have 1, 2, 4. Because 1, 2, 4 with 1, 2, 3, 4, 5 intersect, it's still 1, 2, 4. So this is 1, 2, 4. Okay? Yan. Yan. So correct nyo lang yung sa slide. Next is intersect null with neighbors of 3. So basically, it's null. Okay, again, what's the use of X? X are vertices that needs to be excluded from our R. Our R is the potential maximals or clique. In this case, nothing to exclude R from. P are potential vertices. So meaning, you can choose to include 1 to 4 sa 3 so that we have a potential maximal. In this case, 4 is later going to be figured out that it belongs to another maximal, which is 4, 3. And 1, 2, 3 is another maximal. Okay, 1, 2, 3. So these are potential because this will be branching out. Okay, magba-branch out kasi. So from 1, 2 to 4, 3 to 1, 2, 3 to 4, 3. Okay, so next is we're going to call this subroutine again and then choose another pivot again. Okay, that is where these two left and right nodes. Yan, recursion. Okay, so we're going to choose a pivot again by union of of P and X. So this is our P and this is our X. Okay, union. Let me write the solution here. So union of P and X. Yan. So P is 1 to 4. Since X is null, basically union it will also result to 1 to 4. Okay. Next, we're going to get the values of U. If U is 1, if u is 2, if u is 4. Same with this. Okay, and then perform an intersection of P. Yan. Okay. So, what are the neighbors of 1? Neighbors of 1 is 2 and 3. Okay. Neighbors of 2, 1 and 3. 1 and 3. Okay. Neighbors of 4, it's just 3. Yan. Okay, intersection. So, since this is P, intersection will result to just 2. Okay? Ayan, 2. And then intersection will result to just 1. Okay? Intersection will result to null. Ayan. So, since we have 2 value that is equals to 1, meaning having 1 value or vertex only, you're going to choose the one, okay, that is the first. Okay, yan. So you choose the first one over the second. Okay? Alright. So next, let's solve for this one. You're going to substitute the value of u. Okay? U is 1. Okay, what are the neighbors of 1? We have 2 and 3. 2 and 3. Yan. Okay, neighbors of 1, 2 and 3. Okay, next, what's the value of P? It is 1, 2, and then 4. Okay. Yan, so we have 2. 3 is nowhere here. Okay, so we have 1 and then 4. Okay? Yan, we have 1 and 4. Okay? Alright. Ayan. So, we have now, this is 4. B is equals to 1 and B is equals to 4. Okay? Yan. Alright. Okay, so let us solve for R, P, and X, because after determining how many times are we going to repeat the following statements, in this case, B is 1, first iteration, second iteration, B is 4. Okay, so for B is 1, yan, union it with R. Okay? So, since B is 1, union it with the value of R. Since R is 3, so this is 1, 3. Okay? 1, 3. You can see R here is 3. Union it with B is equals to 1. We have 1, 3. Okay. Next, we have neighbors of 1. So, what are the neighbors of 1? It's 2 and 3. So, this is 2 and 3. Okay, neighbors of 1, 2, and 3. And then, what's the value of B? It's 1, 2, 4. 1, 2, and 4. Okay, intersection. We have 2. Okay, so this is 2. Yan. Okay, and then for X, it's just null, intersect null. So, there's no excluded vertex. Yan. Okay, so, let's proceed sa next iteration. Once you are done solving for R, P, and X, you're going to use the following values as parameters for R, P, and X. So this is now 1, 3, 2, and then null. Okay, and then you're going to create a pivot again. Ayan, so you're going to union P and X first. Okay, so let's solve for the next. So union of P and X. So what's the value of P here? It's just 2. Okay, and the value of X is null. So it's just 2. Yan. So P union of X. So we're going to solve for this again. Since we only have one number, okay, for u equals to 2, you don't have to do any of this. So u is equals to 2. So you're going to solve for p, neighbor of 2. Okay? Ganyan. Alright? So next, what are the neighbors of 2? It's 1 and 3. Listening ha? Okay, 1 and 3. And what's the value of p? It's just 2. Okay. So meaning, what are the value that is not found here? So it's just 2. So this is basically just 2. Yan. Okay, so our p here is just 2. Okay, this is b equals to 2. Okay, ganyan. Right. So, we are now ready to solve for union of b and r. So, the current value of b is 2. We're going to combine it with r, which is 1 and 3. So, as you can see, it's 1, 1, 2, and then 3. Okay, so if your answer here is 1, 3, 1, 3, 2, it will be considered correct. But for your exam, make sure you sort them ascending. Diba? So, I will not consider 1, 3, 2. It should be lower to higher. Okay, 1, 2, 3. Okay. Yan. Okay, so next, what about P? So, what are the neighbors of 2? Neighbors of 2 is 1 and 3. So, this is 1 and 3. Okay, 2 neighbors. And then, what's our P? It's 2. Intersect. There are no common values. So, it's null. X is null as well. So, since both P and X are null, if both P and X are null, you now have a maximal clique, which is 1, 2, and 3. Okay. So, return. It's like printing the vertex, which is 1, 2, and 3. Okay, next. We need to go back sa previous because we are not done iterating when b is equals to 1. We need to solve for b equals to 4 next. So, b is 1 and then next iteration b is 4. Okay, for b is equals to 4, ayan, 4 yan. Okay, we're going to assign values for the following rp and x. Okay, since b is 4, we're going to union it with r. So, union 4 with r. Okay, so since b is 4 and r is 3, so we have 3, 4. Okay, so this is 3, 4. Yan, 3, 4. So ascending. Okay, what about p? So what are the neighbors of 4? Neighbors of 4, it's just 3. 3. Yan, 3. Okay, what's the value of p? It's 1 to 4. Okay, so what are the common values? We have 3 and we have 1 to 4. P is 1 to 4. Neighbors of 4 is 3. So there are no common values, di ba? Okay, wala. So it's null. Null. Since P and X are both null, we print the value of R, which is 3, 4. So you now have a second clique, a maximal. So we have 1, 2, 3, and 3, 4. Okay, next, since B is 3, we're going to iterate again and go back and go sa B is 5. Because previously, this is 3 and then it needs to go sa 5. We have 2 iterations only. Ito naman, B is 3 and then B is 5. Okay, so for B is 5, we're going to solve for the following again. Yan, so we have this. B is 5, union 5 with R. So the current value of R is null. Combine it with 5, you have 5. Okay. Next is neighbors of 5. Null. Null intersect with 1, 2, 3, 4, 5. So since there is a null somewhere here, intersect that with null will result to null. Okay, since both P and X are null, we return 5 as our third maximal. Yan. So meaning, we just improve the algorithm and then we perform a purge. Diba? So purging meaning, you're not going to include the nodes that we don't need to reduce the time and space. So in this case, these two nodes are not going to be recursed or included during recursion. So we reduce the number of nodes in our recursion tree, okay, from 11 to just, okay, correction, to just 1, 2, 3, 4, 5, okay, 6, to just 6 states, including this one, of course. So 1, 2, 3, 4, 5, 6. Yan. Okay, so ano nyo lang yung correction. Okay, mali yung slide. Yan. Alright. Okay, so that is how we solve pivoting. Okay, questions? So for your exam, you will not be given the algorithm.